in number 5, it says graph the equation in standard form. And so this one is the one where we cover up each part and solve. So to find the x, I cover up the y, and I see the equation 3x equals 12. And so to solve for x, I divide by 3, and we get that x is 4. So I put a dot on the x-axis at the 4. Then for y, I cover up x, and I have positive 4y equals 12. So I divide both sides by 4, and I get that y is 3. So on the y-axis, I go to the 3 and put a point. Then I would go ahead and connect those 2 points to make my line. Okay, in number 6, we have our slope-intercept form. So this is our m, this is our b. So we're going to start at 4, because you always begin on the y-axis. Then we're going to go down 1, right 2, because 2 is positive. So down 1, right 2, down 1, right 2, down 1, and then right 2. We also can go the opposite. We can go up 1, left 2, up 1, left 2. Now, this right here is a less than or equal to, so this means that you're going to draw a solid line, and less means that you shade down. Okay, so I draw a solid line, and I need to shade below or under my line. Okay, if it helps you, you could go back to where you begin and draw a little line down, and you can see that this side is the part that you would shade. Okay. In number 7, it says write an equation in slope-intercept form of the line containing the points -4, 6, and -1, 3. Now, we do not have a slope and we do not have an intercept. So the first order of business is to find that slope by labeling the points and then plugging them in to this formula, which is given to you on the front of your test and also on the front of your review. So y2 minus y1 would be 3 minus 6. And then I take x2, which is -1, minus a -4. But we know that those become a positive. So we have -3, and then this subtracts to be positive 3. So m is -1. Now that we know our slope and we have a point, we can plug these two things into point-slope form. So y minus y1 is 6. M is -1, and then x1 is -4. So this becomes positive. Then I would go ahead and I distribute this -1 to transform this equation to slope-intercept form. So -1 times x and -1 times positive 4. Lastly, I add 6, and I have y equals -1x plus 2. So this is my final equation in slope-intercept form. Okay, number 8, when you're given exponents with parentheses, you're going to want to multiply. So 5 times 4 is 20, and 5 times -3 is -15. We've discussed that you can't keep a negative exponent, so I put that over 1, and I want to put the y at the bottom. Okay, in number 9, we subtract exponents. So 5 minus 2 is 3. 9 minus 3 is 6. And then for z, 7 minus 4 is 3/9. But we discussed, too, that if you have a fraction that can reduce, you should reduce it. So we would have x to the 3rd, y to the 6th, And then we can divide 3 and 9 by 3. So 3 divided by 3 is 1, and 9 divided by 3 is 3. Everything has a positive exponent, so I am done with that one. Okay, and then in number 10, we have to graph the exponential function. Alright, so first thing, you always use -1, 0, 1. Okay? Then we start plugging this -1, the 0, and the 1 into the function. So for the -1, I've got 4 times 2 to the -1. Okay? So I can't have that negative, so I bring that to the bottom. And 4 divided by 2 is 2. Then I plug the 0 in for x. So 4 times 2 to the 0. Well, 2 to the 0 is just 1. So we have 4 times 1 is 4. Okay? And then lastly, we have 4 times 2, and we plug the 1 in. Well, 2 to the first is 2. So 4 times 2 is 8. And as you can see, because this is an exponential function, the 2, 4, and 8 should be growing exponentially, meaning that I can multiply 2 by something to get 4. So 2 times 2 is 4, and then 4 times 2 is 8. So that times 2 is the same. It's very consistent. So when I go ahead and graph it, so I'm going to go -1, 2, 0, 4, and then 1, 8. And I draw a curve that approaches the x-axis but never actually touches it.